Hi, everybody. Scott Holstein here. Welcome back to the Building Technology Podcast. Today, I'm joined by Tim Skell of ABB. Tim is a sales application engineer with 17 plus years of experience in VFDs, with the last 9 with ABB, based out of New Berlin, Wisconsin, VFD manufacturing facility. The bulk of Tim's experience is applying VFDs in the HVAC and water and wastewater industries, but he also spent some time in the industrial drive world as well. He's active in the BACnet community, including receiving BACnet Member of the Year award. Tim is a graduate of the University of Wisconsin-Platteville with a degree in electrical engineering. Tim, welcome to the podcast. How are you today?
I'm doing excellent. Thank you.
Really appreciate you joining us. Tim and I had the opportunity to talk a little bit before the podcast. Obviously, we know ABB is a big name in the drive industry. So really excited to pick somebody's brain with so much experience, which, we are today. We're going to get into VFDs, or variable frequency drives. And Tim's going to tell us how they work, what maintenance we can do as facility engineers, and what the opportunities are in terms of getting the most out of these pieces of equipment. But before we get into that, Tim, obviously I gave a little bit of an introduction for you here, but want to get to know a little bit more about you. So how did you end up, obviously, with electrical engineering? I suppose VFDs and that industry made sense, but how did you end up in this field? And is this where you want to be ultimately? I mean, it seems like a industry that's very well suited for you.
Yeah, we joke in the VFD industry that once you get the drive stink on you, you can't wash it off. So when I look at my first, I'll call it real job, would be when I was back in school on an engineering co-op. It was with washers and dryers, and those had little drives in there to control how fast your washer or dryer was spinning. So that was my first exposure to it. And then when I graduated and started looking at the opportunities, I had an opportunity to get in with a drives company, and it was a small one. They had a lot of different really neat applications. And I got into it, and I just stayed with drives. I've been doing drives for basically my entire career. And really all I've really changed is which applications I'm focused on. Started out early on with a variety of more industrial-based applications. Then I moved into the water and the wastewater world. And for the last 9+ years, I've been focused a lot on the HVAC side.
That's great. And I understand you're working in the manufacturing plant in Wisconsin?
Yep. So I'm based out of the New Berlin, Wisconsin manufacturing plant. So we're one of those few companies here that are still building drives in the good old US of A. So it gives me a lot of advantages, because if there's a question on something, I don't have to pull up drawings or a bill of material. I can just walk right out on the production floor and see what's going on. If there's an oddball part that somebody needs that's not typically a replacement part, or it's a screw that they dropped and they can't find it, I can just go on the production floor and ship it out. So there's a lot of advantages for me being based out of the factory. I definitely enjoy that compared to some of my previous companies where I wasn't necessarily at the place where we were building the products.
Yeah, I can totally agree with you there. CompuTrolls does the same thing. It's all under one roof, just outside of New Orleans, Louisiana. We're manufacturing all of our boards, designing the software, et cetera. And having those resources right there, it just makes all the difference. So that's very cool. So Tim, as we get into our conversation here today, I want to start with the very, very basics of VFDs. Well, first off, what is a VFD and how does it work? Let's start at the most basic level.
Sure. So VFD, variable frequency drive, you'll hear it called a lot of different things: adjustable speed drive, variable speed drive, inverter, are all different terms you'll hear for it. And ultimately what it is a power conversion device. Just like when I go camping, we'll call it glamping because it's not real camping, where I have an air mattress that I need to blow up, and I don't want to blow it up by hand. So I've got a little inverter that I stick into the cigarette lighter of my pickup truck, and that turns that 12 volts DC into 120 volts AC, and then I plug in my air mattress pump into that, and I blow up my air mattress. So that's how I can get that done. Now, drives are just same thing. It's a power conversion device. So it takes 480 volt 3-phase coming in from the wall. So not your 120 volt like your TV's plugged into, but good power 480 volt 3-phase. So your higher power devices. And it converts that into something different. It's a different voltage and a different frequency, and it sends that out to a motor. So when you give a motor full voltage and full frequency, it runs full speed. You give a motor half voltage and half frequency, it runs at half speed. So we manipulate that voltage waveform going out to the motor, and that's how we can control how fast that motor goes. And you'll see VFDs in a lot of different applications. So I'll talk about HVAC a lot just because that's where my background is most recently. But if I go back to the early days of industrial applications, so conveyor applications, rock crushers, anytime there's a motor where you need to vary the speed on it, there's a VFD there. One of the fun ones, I'm not sure what to classify this application is a pitching machine. So I've worked on VFDs where it's not just the simple softball pitching machine, but it's a 3-axis pitching machine. So you get a drive and a motor on 3 different wheels. You got two vertical wheels and one kind of angled. And then you run those wheels at different speeds and get sliders and curveballs. There's one called the Randy Johnson profile. So it kind of shows you the age I was in back when I was working on that project. Randy was still one of the big name pitchers out there. So a lot of really neat applications that drives get used on. And then if I look at the HVAC side, so you're looking at your typical building, it's your supply fans, your return fans are using drives, exhaust fans, chilled water pumps, hot water pumps, condenser water pumps, boiler pumps, your chiller compressors, the cooling towers. A lot of different applications are using drives in the HVAC world.
That's the pitching machine example. I love being a former baseball player myself, and it sounds like there are VFD drives VFD drives, I guess, in a lot of products that we don't even consider. We kind of take it for granted. Now, in terms of applying them to, let's say an older piece of equipment. So, we talk about VFDs on air handlers a lot. Is that, first of all, I just asked the question, can that be done? And what is that ultimately going to result in if you put a drive on a piece of equipment that historically has either run full blast or not at all?
So you can definitely do that. There's a couple things to keep in mind. First thing is to figure out the control aspect. So where you really get the benefits of a drive is because you're using the drive to control the speed of the motor. So if the application didn't have any kind of controls in there already, controls will need to be added to it. The nice thing with a lot of VFDs is they have a certain amount of controls built into it. So for example, if I had a supply fan and I was using some inlet guide vanes in the past to control the airflow and to control duct static pressure, I could basically take those out, put a VFD on that supply fan motor, put a pressure transducer, so controls contractor can come in, put a pressure transducer in there, wire that back to the drive, and now I tell the drive how much static I want to maintain in that duct. So there are some controls in the drive, but it's not going to be as simple as just taking the drive of the magic box and sticking it on the equipment and having it take care of itself. There's some extra steps as far as the control, because it's really the variable speed part we have to take advantage of, and we have to have the drive know what speed to run at, and that's where the feedback devices come into play. The other part I should also mention is if we're talking an older motor, some of those older motors were never meant for drives. So if you got a motor that you have to kind of wipe a lot of the dust off to see the nameplate, there's a good chance that motor was never meant to have a drive on it. And I won't get into the deep down technical aspect of it, but they do make motors that are called inverter duty rated motors. So they're meant for drives. If you have an older motor, so a motor not meant for a drive, you need to make sure that the drive is installed very close to the motor. Otherwise, you get something called DVDT or voltage overshoots. You can actually burn out that motor if you get these long distances. So again, that's only really an issue with older motors, but it's something to keep in mind. So if you have a situation where you're looking at energy saving projects and you can say, okay, there's no drive on this today, let me put a drive, make sure you're working with a good knowledgeable VFD provider who can help answer some of those questions is, hey, do I need to change the motor out too? Or, hi, how do I do my controls to take advantage of the variable speed aspect of putting the drive on here?
Great. And can you talk about some of the obvious benefits of the VFDs? And I know that with a lot of HVAC upgrades, at least there is an expectation for a particular ROI, whether that be, a percentage of energy usage, or this will pay for itself by X amount of, months, or however you want to quantify that. But can you talk about the benefits, particularly on the energy saving side?
Sure. So I'll start out from why you're using the VFD is going to that flow control aspect. The whole reason you're putting the VFD in there is to be able to vary the speed of the motor so you can control the flow, whether that's air or that's water. So these are typically in HVAC, they're called variable torque applications. So they're really, as you speed up that motor, that's when it really needs all the torque and all the horsepower to get the job done. But as you slow down that motor, there's very significant energy savings involved. So there's something called the affinity laws, and that's where the energy savings that we want to take a look at. So without making this a math test here for you, the most common example that folks will use is that the power consumption, the ratio is called a cube of the speed. So let me give you a real world example here. So let's say I'm running a fan at 100%. So full speed, full load all the time. If I was to put a drive on that and slow that fan down to 90%, so I go from 100% to 90%, if I try to figure out how much power now that it needs, I take 0.9 to the third power. So that was that whole cube thing I referenced. So 0.9 times 0.9 times 0.9, it's roughly 73%. So per the affinity laws, if I drop the speed from 100% to 90%, I save almost 30% on my energy consumption. Now, it's not quite that perfect. There's some other inefficiencies and things like there. So real world, it might be closer to 24, 25%, but it's absolutely huge from an energy savings just to go from 100% to 90%, almost roughly a 25% savings overall. How much that means to the individual application or the individual building really depends on what that load profile looks like. So if it's an application, if it's a bathroom exhaust fan that you just have running at full speed all day long and you're not really ever intending to slow it down, there's not really going to be much energy savings there by putting a drive on it. You have to slow it down. But if I have a supply fan that really only needs to go full speed at 1, 2, 3 o'clock during the day when the building is fully occupied and the sun is beating on it, but then earlier in the morning when the building's not occupied, or in the evening when there's fewer people there, now that supply fan can slow down because all your VFDs are pinching down a little bit. Now that's where you really get your energy savings. So there's some different bell curves out there for kind of some ASHRAE rule of thumbs. But in general, I would look at a return on investment right around 2 years, year and a half to 2 years by installing a drive on an application that didn't have a drive. But again, it really comes down to that load profile. If it's something where that fan or that motor on that pump, for example, might have been way oversized, you're going to get a much faster ROI. I've seen them before where they're much less than a year. So it really depends on the application and how much you can slow it down. One of the other benefits, other than just energy savings, is how easy it is drives are on equipment. So if you didn't have a drive in the past, then what typically is on them is called a starter. So it's basically a big old light switch. All of a sudden you want that fan to turn on, the contactor, that starter pulls in, and you might hear belts squealing and making noise. My wife hates it when I give this analogy, but there was once I was at an event with her family. Somebody had passed away. I was awake. It was a very happy environment as far as celebration of his life. But it was wintertime and the air handler kept kicking in. And whenever the air handler kicked in, the lights dimmed down. And me being an HVAC guy, I know exactly what is going on. And I kind of surprised they don't put a drive or at least a soft starter on there to stop it. But after the second or third time, people started looking around the room like he was trying to talk to him from the afterlife because the lights kept dimming down occasionally. But again, me being an HVAC guy, I knew what was going on. But had they had a drive on that air handler, the lights would not have been dimming down because you don't have that big inrush on that motor. And again, it's the mechanical wear and tear, the squealing on the belts, on the equipment, that by soft starting the motor is what a VFD does, is it brings it smoothly up to its target set point, opposed to bam, slam it across the line. Which is a lot harder on the equipment. So when you look at the benefits of the VFD, yes, you got your flow control, so you don't have to sit there and use valves or other ways to control the flow. You've got your energy savings because you're slowing things down. And it's a lot easier on the equipment because it's not going immediately to full speed. And then I suppose if I'm going to give one more analogy or one more story from the personal life, going back to some of the energy savings aspects. So talking about the math equation, sometimes that's not very fun and exciting. So I'm going to do another example where when I was a kid, I remember my dad always making fun of my grandma who would drive the car with both her feet. So it wasn't a stick shift, it was an automatic. Left foot was on the brake, right foot was on the gas. So there was times she was pressing both pedals in order to go a specific speed. So you're wasting a lot of gas, you're wasting a lot of energy by pressing the gas and pressing the brake at the same time. So traditionally, when you don't have a VFD, that's essentially what you're doing. You've got a VFD running a motor, and there might be a valve in there that's kind of pinching down a little bit, and that's what's restricting the flow. But you're still sitting there with your foot on the gas, the motor's running full speed, and then you're using a valve to control how much flow. So that's you pressing the brake. So by putting a VFD on these applications, it's that analogy. Don't drive your car with a foot on the gas and a foot on the brake. You're just using the gas up and down to control your speed when you're talking about a VFD. So that's one other story I'll share from my my younger days.
Yeah, I mean that makes a lot of sense. I think from a logical standpoint, thinking that maybe the funeral home knew that they had they could take advantage of VFD or a soft starter, but the people who came, they had this feeling that somebody was still with them. So maybe that was all part of the plan. But thinking about you're talking about the getting just starting right off the line. I mean, you could make an analogy to the human body. If I went outside right now and just went into a full sprint, chances are I'd hurt myself. And if I continuously did that, chances are my body wouldn't last too long. So I think I think a lot of things in life, if you just go full blast off the start, aren't going to last the way that they should. So I appreciate those examples. And, one of the things I want to cover here for our facility manager listeners is maintaining VFDs. So we have maintenance schedules on a lot of our equipment throughout the built environment. And I just wanted to get to you to talk about, what kind of maintenance is required on a VFD, and can any of that be done by a facility manager?
Yeah, definitely. There's certain things that can be done. I'm going to start out by saying drives are electrical devices. Treat your VFDs just like you would your personal electronics. I have a nice receiver and a 75-inch TV. Every once in a while, I pull out my receiver and I pull out all those dust bunnies that are back there, because I know with any electronics, including a drive, the cooler I can keep it, the longer it's going to last. When it comes to electronics, heat are one of those very big enemies. So you want to keep a drive as cool as possible. Now, granted, sometimes you're in a mechanical room that might be 100, 105 degrees. That is what it is. But at the same time, if you're in that mechanical room that's 105 degrees and the drive is dirty on the inside, now it's harder for the drive to get cool, and it's going to have a shorter lifespan compared to a cleaner drive that was able to cool itself better. So as from a preventative maintenance aspect, locally, what I'd say, definitely your cooling fans. You can change out your fans. You can check the IONMs on the particular drives that you have. 6 years is usually a pretty good rule of thumb on when you want to change out your fans. If you're pushing 9, that's probably more than I'd be comfortable with. So 6 years, every 6 years, change out your cooling fans. Really depending on the environment the drive's installed in. If it's a relatively clean mechanical room, you could probably go years without having to clean it. If it's one of those mechanical rooms where everything's got dust coating on it and you got to take your finger across the label of something to find out what it is, that's going to need a much more often having it cleaned out. Usually what folks will do is they'll pop the cooling fan out and take compressed air on one side and a shop vac on the other. So you're blowing on one side, sucking on the other. So that way, as you blow dust out of the heatsink, that's the big metal part in the back, you're not just blowing it across the room or blowing it in other circuits. You're immediately sucking it up with your vacuum. So that's kind of a good rule of thumb. You want to make sure any kind of compressed air you're using doesn't have oil in it. So if you have a compressor that's got the oil in it, what ends up happening, you get that oily compressed air blowing into the drive. Well, now when everything kind of dries down, you get that oil residue on the metal, And now the dust and the dirt just loves to stick right to it. So you can actually do more harm than good if you have oil in your compressed air. So nitrogen, I've heard people use. There's different ways to do it, but mainly keeping your drive cool by keeping it clean is very important. I always like to, when I go out to a site, I take a look at physically where it's installed. So one of my pet peeves is when somebody installs it right underneath a chilled water pipe and that chilled water pipe's not insulated properly, or there's a certain spot where the insulation is not as good, so it drips. So you want to make sure your drive is not installed underneath something that might condense and drip on it. Again, I'm going to go back to always ask yourself with your personal electronics, would I put my laptop right where I have this drive? Would I put my receiver, my PlayStation 5, if you can ever get one, out there? Those are all things you can kind of keep in mind. Cooling fans are something typically you can replace locally. There's other things in the drive that can be replaced that are replaceable components on larger horsepower sizes. But quite frankly, things like capacitors and IGBTs, you're probably more at risk of damaging something than you are at helping something by proactively replacing some of those things, unless you're a trained professional and very experienced in it. So from a local, what you can do in your own building, keep it clean, keep it cool, keep it dry, change out the cooling fans as needed are very key items when it comes to maintenance.
Yeah, that's great advice, and sounds like something that most building engineers should be able to do for the most part, at least. Now, let's say I'm a building engineer who's got 5 buildings around town, and I'm very dependent on my service partners. How often and what kind of a maintenance agreement would you recommend? Obviously, you talk about various areas where these drives live, and it's going to depend. But can you give us just a sense for what you think a reasonable maintenance schedule would be for your VFD provider to be coming in?
A lot of folks will use a 3-year rule of thumb. It also depends on if there's other equipment that maintenance person is going to be taking a look at, that provider is going to look at. If they're going to be in looking at air handler belts and other things of that nature, and they're going to do that on a yearly basis, then it may make sense for them to kind of pop their head in and check the VFDs, maybe not do a full maintenance on them, but there's certain parameters they can check in the VFD just to check how many amps it's drawing and make sure it's not being overloaded. So there's kind of some basic tests they can do without having to do a full PM on it. When it comes to the deeper PM on it, every 3 years is a good rule of thumb. But I'm never going to say you can't check on it enough, because quite frankly, a lot of people look at VFDs as this magic box that they hang on the wall, and they completely forget it's there until it fails.
Right. Yeah, that's a great point. So for our facility managers out there who are evaluating service partners in this industry, what are some tips you would give them to differentiate one service partner from another, or one manufacturer from another?
Definitely start out by asking if they stock the product. So there's a lot of people who are service folks, but they're not necessarily the ones who are also selling the product. So they might service a lot of different versions or manufacturers. What ends up happening is they can be a jack of all trades, but a master of none. So I would start out by going to the person who you typically source the VFDs from, and I'd also check to see if that person stocks them. And then also if they say, oh yeah, sure, we stock, drill down a little bit deeper, maybe give them a model number of one you've got, or point to one that you've got and say, hey, if this unit was to fail today and I needed to get a new one, do you have that on the shelf back at your office, at your warehouse? If the answer is yes, you're probably 90% of the way there to finding out that having the best guy to be your service person. You can find out how long they've been servicing the particular brand of drives that you have there locally. If they've just started carrying that line, they're not going to have the same expertise as somebody who's been carrying that line for a longer period of time. Asking questions about who their top techs are. It doesn't matter what their name is, but hey, your top 3 techs, how long have they been in the industry? If the answer is 3 years and 5 years, it's probably not the right company if their top techs only have that limited experience. So experience and working with that brand of drives that you have installed locally are definitely key. And then lastly, it's kind of that word of mouth. So I'd say talk to your peers. So I like to participate in my local ASHRAE chapter meetings, and I get to meet some really cool people. It's the mix of both the manufacturers, the building engineers, the chief engineers. You get a nice mix there. And I know it's different where you are in the country, but definitely leverage your local ASHRAE chapter meetings. You can talk with your peers, your fellow chief engineers and facility folks, and find out who they're using. And they will give you a very honest answer. And sometimes hearing from your peers is just as valuable as anything else.
I love that advice, Tim, especially, when you're talking to a mechanical contractor, and if it hasn't been brought up by them and you say, can you all service VFDs? I think a lot of people are going to say yes to that question. But to your point, there are a lot of people who can. There are probably a lot fewer who do it well. And I think that you just gave a great list of questions in terms of how to evaluate those service partners. Now, in terms of manufacturers, are there any differentiating factors from one VFD manufacturer to the next?
Sure. Some of these will get a little bit deeper, so I'm going to keep it high level, and we can always talk about these in more depth in the future. But there's something called harmonics. VFDs, as awesome as they are, the energy savings, how easy as they are in the equipment, the way they draw power from the grid is they gulp power. So they don't draw it continuously, they gulp it. So it's called a nonlinear load. So when I look at VFD A versus VFD B, it's not necessarily brand A versus brand B, it's design A versus design B. So I've got lower cost drives who are going to gulp more current, so they're a little bit less efficient, and they create more harmonics. This is kind of noise that goes back onto the line. Then I have other higher end drives that have reactors, impedance, and what that does is it acts like a buffer. So when the drive tries to gulp that current, it basically says, no, you can't draw that much current so quickly. And that drive actually draws less overall current from the grid. So where this comes into play is really what type of building are you in? If I'm at a university and I got labs, I do not want dirty power in my building. I want nice, good, clean power. If I'm a hospital, I'm a data center, I'm supporting or I'm near an airport, those are all situations where you want good, clean power. So there's drive technologies that make sure they don't distort the power at all. And then, of course, there's going to be different technologies from different manufacturers. But basically, every manufacturer's kind of got like a good, better, and a best. So we kind of rely a lot on the consulting engineers when they're designing new buildings to make sure that you guys are getting eventually an installation that's not going to cause any kind of power line harmonic issues. And if you're curious on it, just do a Google search on power line harmonics or the word IEEE 519 with drives, and there's all kinds of data out there on the topic.
Awesome. Really great answer. So before we get signed off here, Tim, I want to talk to you about some of the latest and greatest things happening with VFDs. Obviously, it's somewhere you've been for a long time. I'm sure you've seen changes in the industry in your years working on it. But what are some of the new trends with VFDs, new technology, new use cases? Can you talk about that a little bit?
Definitely. So what's interesting is in some cases, some of these new trends aren't really new in terms of the technology. The concept's always been there, but people are finally applying it. So for example, HVAC drives typically come with BACnet. BACnet is a communication protocol that lets all your different devices all talk to each other. So your building automation system can reach out to the T-Stats and the VAV boxes and the VFDs and all the other widgets and gadgets that are part of the HVAC system, and it can talk to it and it can ask questions and get answers back. So years ago, it was the very most basic start, stop, here's your speed control. Am I running? Yes or no. But we're finally to the point where people are seeing the value in big data. So as an example, I can have my building automation system ask my drive, how much power are you outputting to the motor? And the answer might be 10 kilowatts. So it can ask every one of the drives that piece of information, and the building automation system can then trend that. So I can compare my supply fan drives to each other. So if I have 3 air handlers that really should be are identical to each other, and they feed kind of very similar places, but I see one of those 3 air handlers is drawing more power than the other 2, it raises kind of a red flag for me. Okay, I need to go in here and take a look and what's special, what's going on, what's different, what's wrong, why is this one unit drawing more power? Years ago, if I wanted to do that, I would buy a separate power meter and I'd be installing it in front of all my air handlers and all my pumps and paying a lot of money to get all my integration and logic done. Now this data is free. It's in the drive over BACnet. You don't pay extra for it. All you need to do is let your controls contractor know that they need to bring that point out to be trended. So you pay for 15 minutes of labor per drive to get that done and trended. Is really your only real cost to it. So there's energy savings above and beyond just what you naturally get from the drive by able to look and troubleshoot your building and learn where your power is being consumed. So the data over BACnet being power consumption is one that's becoming more common. The other one over BACnet is monitoring the status of what mode the drive is in. So drives, they've got this hand mode and they have off and auto. So if you walk up to a typical HVAC drive, you're going to see this HOA, hand, off, auto, 3 distinct buttons. Almost always your drive should be running in auto. That means it's following a 0 to 10 or 4 to 20 milliamp signal coming from the building automation system, and it speeds up that pump or that fan up and down as needed based on what the BAS says to do. Every once in a while, you might have an issue with the BAS. Things go down. Maybe a sensor's gone down and it's all out of whack. And you need to manually override things and basically come in and you put the drive in hand mode. You press that hand button. Then you got these up and down arrows on the keypad. And you say, okay, I need to speed it up or I need to slow it down. And you manually do that, which is absolutely fine. That's the whole purpose of this hand mode is when you know what hits the fan and you need to get equipment up and running and move the air through your building, you put things in hand. But that's meant to be temporary. There's been so many sites I've walked out to do some troubleshooting. Usually it's unrelated to this, but I walk up and I'm like, hey, I see you got 6 drives here and 2 of them are in hand. How long have they been in hand mode and why are they in hand mode? Well, I'm not really sure. I didn't even realize they're in hand mode. And I walk over and they're at 60 hertz, which means full speed. So remember I talked about you install drives so you can save energy and control flow. So they're sitting there in hand mode. So what people are doing better now on is they can set up alarms in their building automation system to trigger that. So if they see that the drive is in hand mode because the drive is talking to the BAS over BACnet, the drive will say, hey, I'm in hand mode, FYI. And then a good building automation system will then trigger that as an alarm to continuously remind the chief engineer, the facilities person, that, hey, this drive is in hand mode. Don't forget about it. Once you've got the core problem fixed, go ahead and put it back into auto mode. So that's another trend where it shouldn't be new because that concept has been available for the past 10 years. It's just finally we're getting the message out there. The controls contractors are understanding it. One of the toughest things that we deal with in the HVAC industry is quite often the person who got the job is the lowest bidder. And the lowest bidder too often is trying to do the bare minimum that was specified and then move off the job onto the next project. So sometimes some of these trending of data things kind of slip through the cracks. But as the controls techs are learning how easy it is to set these things up, some of them are starting to do it even if they're not asked for. And then you as the facilities person, if you ask to have it done, they can definitely do it. Some of the other things I would say as far as new trends would be getting away from parameters. So it's not uncommon for a drive to have 500 to 1,000 parameters, and it's quite silly. I mean, there's no need for this many parameters for 99% of the applications, but there are some of those oddball scenarios where you need this extra parameter to change this feature or that feature. So what you're seeing is the parameters are still there for everybody who's old school, and that's how they learned it. But drives are also having more, I'm going to call them settings. In ABB's HVAC drives, we call them primary settings. So if I look at my iPhone, for example, I don't sit there and configure my iPhone by changing a bunch of parameters. I go into the settings, I look in general, and I kind of just follow plain English and common sense, and I can navigate down to what I need to adjust. That's how drive primary settings are. So if you've been using some of the older drives that are parameter based and you're like, man, there's a lot of parameters in here, I wish I didn't have to deal with this. Look at some of the newer drives that have these primary settings based configurations. And they're even including cheat sheets. So for example, I used to teach a whole bunch of authorized startup classes to mechanical and control contractors who were doing the first startups on drives. At the end of the entire day class, I'd always say, hey, Tim, we went through a whole bunch of parameters, but what are those key parameters I would need? And I'd list off the 10 parameters. They'd get their books out. They'd highlight them. They'd dog-ear those pages in their manual so they had them. They might put them on the front page. So now that we've moved forward and we've moved to the settings approach, what we've done is put these quick setup settings in the drive. So what happens there is you don't have to go through and sort through a bunch of different settings to find it. There's a cheat sheet list of those 10 most common settings that you need. So from the usability aspect, that's been helping folks out a lot. It's just they're friendlier to use. And then I guess one last usability aspect I'll add to it is you're starting to see drives with Bluetooth functionality now. So I can actually take my iPhone and connect it via Bluetooth to a drive. I can do controlling and starting and stopping. Yeah, that's all cool and stuff, but what real world value does that have? Where the real world value comes into play is I can pull parameters off of that drive up into my phone. I could then email ABB tech support. So if I'm somebody who's out in front of a drive and I need to call up ABB tech support, I've done tech support. I can't tell you how many times I wish I could just be in front of the drive and check and see exactly how it's all configured myself. Well, now you suck all the parameters from the drive onto your phone over Bluetooth, email to tech support real quick. They can pull that up, and it's like they're there with you. They can see all the parameters and exactly how those things are programmed. And even a next step, usually we would kind of walk you through, okay, change this one parameter is going to help you out. But if we wanted, we could even email a new set of parameters to you. You can take them off your phone and then over Bluetooth, download them into the drive. I would say that not everybody is on board with the Bluetooth, just with security as being such an important thing of our industry. So I would say certain hospitals and data centers are kind of shying away from the Bluetooth. And a lot of drive manufacturers, it's an option, either get it or not. So ABB is the same way. So if security is a concern, they usually will shy away from Bluetooth. But for your typical applications, they're definitely starting to use Bluetooth. Works nice as a backup. So after I got all my drives set up, I can suck the parameters into my phone and they can live there, or I can email them and save them on my desktop wherever I want. So that way, if down the road, maybe I had a lightning strike nearby or somebody hit the power pole and it ended up causing a transient and blew out a drive or two, I'd have all those drives were previously programmed on my phone or on my computer, and I could use Bluetooth to dump it right into the replacement drive. So Bluetooth is giving us a lot of functionality. The concept of having apps is really opening up a whole new usability aspect that really weren't with drives in the past.
The Bluetooth feature is really cool. I can only imagine from a tech support standpoint how much easier that's making people's lives. And like you said, it's interesting because in a lot of scenarios, this technology has been around, but it's now either, just being combined with different industries. I always say, from a technology standpoint that, consumer technology moves so much faster than a lot of this commercial technology that we deal with. But to apply something as simple as Bluetooth makes a huge difference. And in other cases, it's just now that it's becoming common knowledge or it's being made readily available. And for everybody listening, Tim just gave you a great piece of advice. Talk to your BAS service partner, and if they're not setting up alarms for drives or honestly any piece of equipment that's in hand for more than specified period of time, call it 24 hours, then that's something that can be easily done on the building automation side. So awesome advice, Tim. Before we get off, I kind of want to open the floor for you. Is there anything else from a VFD perspective or otherwise that you'd like to talk about?
We've hit a lot of the big topics. I'm just going to circle back to, I touched a little bit on that harmonics aspect. And really, if you're dealing with facilities that need to have good, clean, quality power, if you're in charge of a hospital, you've got classrooms that do lab experiments, you need to have good, clean power. Definitely reach out to your local drives guru to have a conversation about harmonics, because it's something that it's a little bit too deep dive to talk about on this call right now, this conversation. However, it's something that's very, very important. And if you've got a lot of drives on the network and the wrong kind of drives, unfortunately, it can distort your waveform and cause issues. But from a energy savings aspect, drives are absolutely incredible. You throw a drive on a piece of equipment, you slow it down, you save energy, your equipment lasts longer. There's so many more positives than negatives when it comes to drives. I kind of joke with when I'm interviewing and recruiting people to come be an application engineer for ABB, is that drives are almost a recession-proof product because of the energy savings aspect. Even when there are downturns in the economy, the first thing we do is how can we save energy? How can we cut costs? And the drives having such a quick ROI are the very first things that folks go to. So it's kind of going back to why I'm in drives and again, not being able to get that drive stink off of me. It's a great product. It's really fun to apply. So if you've got questions, there's a lot of experts at ABB that are happy to answer your questions. And if you don't have a local ABB guy, I mean, to be honest, there's a lot of good VFD guys out there anyway. I'm not going to just toot my own horn. There's a lot of good VFD guys out there to ask questions to.
Well, that's again, great advice, Tim. And the stink of the drive industry makes sense because, like you're talking about, it's a solid investment for just about any facility out there when you look at the payback. And we're talking about getting your money back on that initial investment, but then beyond that, you're saving energy and saving money in the process. So really, really appreciate you taking the time to sit down and talk to us today about what you do. And I think that you've given some incredible advice here, but we'll try to give you also our listeners a few links Tim will supply for us to give you some more information on some of the things that we talked about today. But Tim, thank you so much for joining us.
Oh, it was a pleasure. Thanks for having me.
All right. Thank you all for listening today. This is Scott Holstein with the Building Technology Podcast signing off.